So the scientific method in a really clean format can be laid out in this orientation. And so we're going to be using this figure throughout the entire class just to kind of give you a basis of where we're at in the scientific method. And so I just wanted to present this to you now because it's more of a linear orientation of the process and where we're going. If you are more of a visual person than I am. And so in the previous segment, we talked about the research process being really messy. And I just want to reiterate that comment that this is definitely a process. And so as much as we would love it to be just straight and to the point, and you can get from point A to point B very quickly, a lot of times research ends up looking like this, especially around the design the experiment, collect the data, analyze the data, and make a conclusion part of this process. And so that data analysis process is one of the areas that gets the most confusing. And so it's my goal with this class to actually illuminate a little bit of that process and at least get you familiar with how we analyze basic data sets. And so to observe and come up with an idea for a research project is actually pretty straightforward. We'll talk about it a little bit more in depth with the individual projects, but the first major stop with the hypothesis or with the research project comes when you develop a hypothesis. And prior to this, you're going to be doing a lot of literature review, and we're going to get into literature review stuff during week number 2. And so just to set context a little bit, a hypothesis is really a tentative answer to a question. It takes on the format of if and then. And so, for example, if we predict that if we drop a ball from a higher height, then it will bounce higher. Okay, so that if-then format is really important when we talk about hypotheses. And so hypotheses are an important first or beginning step in that scientific method because it really creates a testable explanation for what we hope to observe. After we develop our hypotheses and we've got that really kind of clean, crisp if-then statement, we can then move into developing our objectives. And so objectives are really the measurable action on item of a research project. And so objectives need to be realistic, they have to be measurable, and they have to be achievable. And we don't always get that when we formulate a hypothesis. Therefore, most research projects will begin with a hypothesis and then have really defined objectives to carry out that process. An objective is going to be very clearly stated, it's going to be unambiguous, usually going to be short and simple, and doesn't have a lot of unnecessary jargon, especially jargon related to a certain discipline, which we have to be careful of in agriculture. And objectives are going to be pretty robust as well. So you could see a peer-reviewed journal that has a big objective and then several secondary objectives. And so those secondary objectives become really important for projects that get really big or over a long length of time. So as an example here, when we look at a plant science example of developing an objective, we may ask an initial question that's pretty broad. So for example here, how are wheat crops best managed to obtain the best yield? Okay, so that's a really vague question. And so in order to get more specific, we have to add more detail to that thought process. And so you may end up with something like what fungicides and fertilizers give the best yield of a wheat crop in the panhandle of Texas. So moving from that first question to the second question, we've added some really important specific information that is going to really drive the creation of our objective. And so we can then take that more specific question and develop an objective to make it actionable. And so we change verbiage around and make it a sentence instead of a question. And so in this example, the objective would then be to determine the level of nitrogen fertilizer that will provide maximum wheat yield in the panhandle of Texas. And so this step-by-step process is something that I want you guys to get familiar with. We start with a really big concept or big question at the beginning. We begin to narrow it down by adding more specifics to it, and then we come up with a very specific, crisp, clean objective. An example in animal science may look something like this, where we start with the question of, will changing the energy in a diet give better milk yields? To make that more specific, we could add some verbiage and to it that says, does increasing the energy concentration of a dairy cow's diet in mid-lactation improve its milk yield? And then we could take that more specific question and change it around to form the objective. And so we change that question into a sentence, and that objective then reads, to determine which of the concentrations, A, B, or C, of a high energy diet in a cow's feed in mid-lactation gives the highest milk yield in Holstein cows. And so that initial question becomes actionable by just going through the process of creating a very specific objective. All right, so here's another example, and we're going to break down what an objective looks like. If we had this example objective where we were looking to determine the potassium efficiency of farm manure applications to sugar beets, this sentence is pretty straightforward, but it gives us 3 key pieces of information that every objective has to have. Okay, so every objective has to have 3 main parts. It has to identify the dependent variable, the independent variable, and the experimental unit. Okay, so once you get past that, the rest of the particulars of the experiment, the experimental design, the analysis process, how the experiment is carried out, is going to be described later in the experimental protocol. And so for those of you guys that have spent time in scientific peer-reviewed literature, this would be the materials and methods section of a publication. So in this example here, the term potassium efficiency really indicates the variable that is going to be measured. Okay, so we're going to be measuring the efficiency of potassium. The independent variable is going to be the treatment. Okay, so the material that is being manipulated. So in this case, it's the manure application. So that is our treatment, or the independent variable. And then the third component to this is the experimental unit. So it's all well and good to measure potassium efficiency and manure applications, but you have to designate what the experimental unit's going to be. And in this case, the sugar beet is the crop under investigation. And so, yes, we could probably define this even further, because we don't know if we're talking about an individual sugar beet plant, an acre, a field, several fields, etc. But this just gives you a really good introductory process to developing an objective. So again, just to reiterate, we need to make sure that we have a dependent variable, an independent variable, and experimental unit defined to have a really good objective. All right, so let's look at another example. If we were to determine the effects of feed treatments on the performance of cows, you can start to ask yourself some questions here. Okay, so in general, do you think that this objective is as good as it could be? Okay, so if your answer to that was no, because it's really vague, we have no idea what feed treatments we're talking about, we don't even know what type of cows we're talking about, and we're missing the more specific information as to what the quote-unquote effects even are, we could then start to ask these series of questions, right? So what aspects of performance are we interested in? Are we looking at behavior, at meat quality, or at growth? Okay, so what sort of feed treatments are we interested in? Okay, and then what breed or stage of production does the cow refer to? And so we can take this example, which is really, really, really vague, and morph it into something more specific during the planning stages of a research project. And so, if we are interested in determining the effects of copper supplementation specifically on reproductive performance of lactating Angus cows, that answers all three questions that we had in the previous slide. So our independent variable here is going to be the treatment that is going to be used, which is going to be copper supplementation. The dependent variable is going to be the variable that's going to be measured or is dependent on the treatment. That's going to be reproductive performance. And then the experimental unit here is not just a cow, but it is a lactating Angus cow. So it gives a very specific experimental unit. All right, so as we look at the scientific method, we're going to spend quite a bit of time talking about the 6 major steps that were presented in the previous segment. Okay, but the full process is really quite long. And so the full process looks like first observing and or suspecting that a pattern exists. Then we have to take into account how big is the overall difference that we're observing. Is it worth even conducting a research project on? After we think about, how significant is the difference going to be and we decide to move forward or not with the process, we can then move into creating a question that would help to explain the pattern that we're observing. And from that question will come the hypotheses followed by the objectives. And then we're going to spend some time designing the experiment. And that's going to be a big chunk of what this class is going to be about. Once you design the experiment, you'll then collect the data. And after you collect the data, you'll then analyze the data using statistical procedures primarily. And once you kind of bring all your results together using statistics, you're going to evaluate the hypothesis. So do you reject or fail to reject the hypothesis, which is designated as HO? And then you'll make the conclusions based on the data. You'll make a notation of any problems that was in the current work. And just keep in mind that research can actually be published that has problems associated with it as long as they don't violate any of the major quote unquote rules of research. And so somebody else could pick that up later on and move that process forward. And then you also want to make sure that you predict future directions for the research to go. And we're going to see this come to fruition when you guys get to the end of the semester and you start developing your discussions and conclusions. And so these parts of the scientific method really fall into place with how a scientific report is created. And so a scientific report could be an extension publication, it could be a peer-reviewed journal article, it could be a scientific talk, etc. But they all have these components. Okay, so they'll have a title, they'll have an abstract, which is just an overall summary of the project. Then they'll go more into depth with the introduction that will give background about the process, ask the questions, and formulate the hypotheses. And an introduction will then end with the specific objectives for the project. From there, you'll go into the methods or the materials and methods. And so this is what was actually done, how we carried out the study. The results section will report just the results of the study. Okay, so all the data will be summarized. It could be put into graphs or tables and presented to the reader. The discussion section, sometimes you'll see combined with results, and sometimes you'll see it as a standalone section. And this is where you have the opportunity to take previous research that had been done and compare it to the research that you or the results that you discovered as part of your project. And then the end of the scientific report will always have a section for acknowledgments as well as references.